Welcome to another video, the same every time, IGCSE Maths, GCSE Maths, looking at the kind of questions that apart from the numbers are the same every time. Watch the videos, learn how to do them, do your own practice, and when you see these on your exam paper, you'll recognize them, you think, I know how to do this, I can do this, I can get myself into the marks, I can get myself into the grades. We're again on differentiation and stationary points. Let's see if we can blast our way through this question. We know how to do all this, I think, by now. So this time, though, the notation is slightly different. So instead of giving us y equals, they're giving us f of x. So f of x equals x cubed minus 3x squared minus 4. So find the gradient of the graph where x equals 1. Well, if we're ever finding the gradient and we're not actually drawing the graph, what we need to do is differentiate. And the only difference between this question and other questions that we've done is the notation. When they write it y equals, then we write the differentiation as dy by dx, dy over dx. If it's f of x or another function letter, g of x, h of x, whatever, then the differentiation has the symbol f dashed of x like that. But the method is still exactly the same. Multiply by the power and decrease the power by 1. Multiply by 3, decrease by 1. That would be negative 6, x to the power 1. And the negative 4, a number on its own, differentiates to make 0. So we want the gradient when x equals 1. Well, the differentiated function tells us the gradient. That's what it is. That's what it's for. So to find the gradient, I just put x equals 1 into my differentiated function. Instead of x, I put a 1. So 3 times 1 squared is 3. Minus 6 times 1, which is 6. 3 minus 6, negative 3. So the gradient of that particular graph when x equals 1, negative 3. Differentiate and put x equals 1 into your differentiated function. And here we are in familiar territory again. Find the coordinates of the turning points of the graph of y equals f of x. So whenever they say turning points, we need to differentiate and put the differentiation equal to 0. Usually it's dy by dx, isn't it? But they're using different notation in this one, so I'm differentiating, I call it f dashed of x. It's the same thing, differentiating, multiply by the power and decrease the power by 1, but it just has a different notation. And the negative 4 there will differentiate to 0. So turning points, put your differentiated function equal to 0. And we have a quadratic equation here. But it's the kind of quadratic equation that does not have a number on its own, so it's just something x squared, something x equals 0. Do not be tempted to divide by x, to simplify it if you like, because we never divide by the thing that we want to find. If you do that, you're likely to lose solutions. What we need to do with this is factorize. So we factorize this one. Look at the numbers. 3 and a 6, highest common factor 3. X squared and x to the power 1. Highest common factor, excuse me, I don't mean that. I mean the lowest power. The lowest power goes outside the brackets. The lowest power of x is x to the power 1. So 3x times what makes 3x squared? 3x times x. And 3x times what makes negative 6x, negative 2. So we have two possible solutions here. Either 3 times x equals 0, which gives us x equals 0, or the thing in the bracket equals 0, x minus 2 equals 0, which gives us x equals 2. So our two possible x coordinates are 0 and positive 2. And they say in the question, find the coordinates of the turning points of the graph. So we've got the x coordinates and we now just need the y coordinates. So we just have to substitute back into the original equation, the f of x in this case. This is the first equation that they gave us. So to find our y coordinates, we substitute back into this one. So when x equals 0, y is going to be 0 cubed minus 3 times 0 squared minus 4. Well, that's all just going to be minus 4, isn't it? Negative 4. So 0 goes with negative 4. And when x equals 2, y is going to be, I just put 2 instead of x into my original equation. It's going to be 2 power 3, 2 cubed, minus 3 times 2 squared, minus 4. So 2 cubed is 8, 2 times 2 times 2. 2 squared is 4, so minus 3 times 4 would be minus 12, and then minus 4. So 8 minus 12 minus 4 is going to give us negative 8, isn't it? So 8 minus 12 minus 4, negative 8, so 2 goes with negative 8. And that's the end of that question. So that's 4 marks there. And again, we've seen these many times before. Find the coordinates of the turning points. Even if you think this is a high-end topic and you're not really confident to get to the end of the question fully, or you know you're not quite there yet, you can still get yourself into the method marks. All you need to do, whenever it says turning points, differentiate, and put your differentiated function equal to 0. Then solve for x, gives you your x coordinates, and then find your y coordinates by putting the x values back into the original function. If the video was useful to you, and I hope it was, then please do consider liking and subscribing. Thank you very much for watching. I will be back next time.